In this video, we will explore the concept of functions in programming. Functions are a great way to structure your code and make it reusable. But simply a function is a block of code that you can call multiple times, often with different input values, and it will execute whatever task you've defined inside. Let's dive into an example, as that's usually the easiest way to understand this. We define a function with the keyword def, which stands for define. Every function starts with this keyword, followed by the function's name. You can name the function anything you like. In this example, I'm going to create a function that adds 5 to any input value. So I will name a function add5. After the name, you add round brackets, where you can pass parameters. Parameters are like placeholders or variables that will be filled with actual values when we call the function. In this example, I will create a parameter called value. You can name this anything you like, but since the user will provide a number, calling it value makes sense. After defining the parameter, we write the code that will run inside the function. Everything within the function must be indented. For now, all we want to do is print the result of the input value, added 5. I will use a simple print statement for that. However, if I run the code now, nothing will happen yet, because the function needs to be called to actually execute. Defining it just sets it up. Calling it is what runs it. To call a function, we write its name and pass values for the parameters. In this case, we'll pass an integer or float for value. Let's run it with a number and we will see that it prints the result right away, because the function is designed to output the calculation. I could pass any kind of number, whether it's positive, negative, or even a decimal. The function will always print the sum of the input value and 5. I can also assign the input value to a variable, for instance a, and then pass that variable into the function. You see that we just pass a number at the parameter position where we used value as a placeholder. If we had more than one parameter in the function and we're not sure about their positions, we could also be more specific and say that the parameter value should be our variable a. Right now, our function only prints the result. But what if we want to use the result in further calculations? We can't do that at the moment because the function doesn't return anything, it just prints the result. To fix this, we need to use the return keyword. Let's walk through another example. This time, we will write a function to calculate percentage values. Imagine we want to calculate the percentage of agricultural land in a country, or the percentage of forest land. We will need the function to return these percentages so we can use them in further calculations. We will define a new function called calc_percentage. The function will take two parameters, one for the specific land area we are calculating, for example agricultural area, and one for the total land area, for instance the total area of the country. We will call these parameters landscape area and total area. Inside the function, we will perform the percentage calculation by dividing the specific land area by the total land area, and then multiplying by 100 to get a percentage value. After that, we use return to send the result back from the function, allowing us to use it elsewhere. Now we can call this function to calculate the percentage of agricultural land in Germany, for example. We'll first define the total area of Germany, the agricultural area, and the forest area. Then we will call our function twice. Once for agricultural land and once for forest land. Each result is saved in a variable. Once we have the percentage values, we can print them out. For example, agricultural land takes up 50.6% of Germany, and forest land covers 29.8%. These values are now stored in variables, so we could use them in further calculations, such as adding them together to see how much of Germany is covered by either agricultural land or forests. As you can see, 80.4% of Germany's land is either agricultural or forest land. In summary, we've learned how to create and define functions, how to set input parameters, how to call functions with actual data, and how to return values for further use. The great thing about functions is their reusability. This function for calculating percentages could be used in many other scenarios. For instance, you could use it to calculate the percentage of urban population in a country compared to the total population, or to determine the proportion of land used for housing in a city compared to its total area.